You're listening to DTFHN for June 25th, 2026. I'm your open source against medical advice host, Jack Paxman. We are your daily tech feed for hacker news, a website where mass decentralized pedantry somehow produces enlightenment. Today, the builders are loud, the gatekeepers are nervous, and the commons keeps winning. Let's get into it. Someone got Half-Life 2 running in a browser tab. The entire source engine, Valve's physics, its lighting, its animation system, executing inside your web browser like it's a JavaScript to-do app. The question nobody in the comments is asking is the right one. Why is this running better in a browser than it does natively on a Mac? One commenter nails it. They literally cannot play Half-Life 2 on Steam anymore because Apple dropped 32-bit support years ago, and Valve never bothered to recompile for 64-bit. A game that sold tens of millions of copies, made by a company worth billions, and the official distribution channel just doesn't work on modern hardware. But some developer working independently got the whole thing running in a browser tab on that same machine. WebAssembly and WebGL doing what a multi-billion-dollar platform holder couldn't be bothered to do. Let's pull this thread. The source engine is a beast. A C++ code base from 2004 with decades of accumulated complexity. Getting that to compile to WebAssembly, getting the rendering pipeline mapped onto WebGL, getting the input handling and audio and physics all working within the browser's security sandbox. This is deep, painstaking engineering work, the kind of work that requires understanding the engine at the level of individual memory allocations and draw calls. You're essentially building a compatibility layer between a native game engine and an entire operating system that happens to live inside a browser. And this isn't an isolated achievement. Quake 3 is playable in a browser. Unreal Tournament is playable in a browser. There's not Clefdal website with hundreds of explorable game levels. The web platform has quietly become the most universal runtime we have. Write once, run anywhere. The promise Java made and never delivered. The browser just did. The comments predictably include someone worrying about the legality of redistributing Valve's assets. And sure, that's a real issue. But zoom out. The fact that a proprietary game from 2004 is more accessible through an unofficial browser port than through its official storefront tells you everything about where closed distribution models end up. The code rots. The platform moves. The gatekeepers stop maintaining the ladder. Meanwhile, the web stays open. The browser keeps running, and someone with enough skill and determination can make a 22-year-old masterpiece playable again. Not by asking permission, but by building something extraordinary. This is builder culture at its finest. Working code, shipping in the most universal runtime on the planet. The tools exist, the craft is real, and the result is genuinely beautiful engineering. We talked about emulation bringing classics back to life. Well, Dolphin just dropped Progress Release 2606, and it's a big one. I once spent 3 weeks debugging a system where two microservices refused to agree on a timestamp format. 3 weeks for a date. So when I tell you that the Dolphin team just shipped emulation of a Game Boy Advance running inside a GameCube, two entirely separate processor architectures talking to each other through a peripheral interface that Nintendo designed in 2003. I want you to appreciate the sheer audacity of that engineering. The Game Boy player was Nintendo's answer to a problem they didn't think software could solve. And honestly, in 2003, they were right. Dadle tried the pure emulation approach, with their advanced game port, and the result was a GBA emulator that ran on GameCube hardware by skipping 2 out of every 3 frames, 20 frames per second. Nintendo looked at that and said, "No, we'll just solder an actual Game Boy Advance onto a board and plug it into the bottom of the console. Hardware solving what software couldn't." This is where the historical parallel gets delicious. In 1994, Connectix shipped Virtual Game Station, a PlayStation emulator for Mac. Sony sued them into oblivion. Not because the emulator was bad, but because it was good. Too good. It proved that commodity hardware could replicate purpose-built silicon. The courts actually sided with Connectix on the legality, but Sony bought and killed the product anyway. That's what proprietary control looks like when it feels threatened by emulation. 23 years later, an open-source project is doing something Nintendo themselves said required dedicated hardware. The feature request sat on Dolphin's issue tracker for 16 years. 16, and a community of volunteers solved it anyway. Not by shipping custom silicon, not by licensing Nintendo's boot ROM, but by reverse engineering the communication protocol between 2 emulated systems and making them talk. Meanwhile, retro achievement support landed for Wii games in the same release. A community-built achievement system bolted onto community-built emulation for games whose original manufacturer has zero interest in preserving. Nintendo's official position on game preservation remains charitably hostile. They'd rather sue ROM sites than maintain their own back catalog. The Dolphin team shipped Triforce Arcade emulation, Game Boy player support, and Wii achievements in a single release cycle. Volunteers building freely. No stock options, no roadmap mandated by a product manager optimizing for quarterly earnings. Nintendo needed custom hardware. The open source community needed patience. Moving on. When does learning become stealing? That's the question at the center of this week's most revealing dust-up in AI. And the answer tells you everything about who is actually worried about progress and who's worried about market share. Anthropic filed a complaint claiming Alibaba used distillation to extract Cloud's capabilities. Distillation, if you haven't encountered it, is straightforward. You query a stronger model, collect its outputs, and use those outputs to train a smaller one. Is how knowledge has always transferred. A student learns from a teacher. A junior engineer reads senior engineer's code. A researcher builds on published results. The mechanism is ancient. The only thing new is the scale. Now here's where first principles matter. What is actually happening when you distill a model? You're sending it prompts. You're receiving text. You're learning from that text. Strip away the legal framing, and you have reading, pattern recognition applied to publicly accessible outputs. The same fundamental process Anthropic used when it trained Claude on by one court's finding over 7 million books downloaded from pirate sites like LibGen. A judge already ruled that wasn't fair use. Anthropic's defense? Research purposes. The court said no. The irony isn't subtle. One company trains on millions of copyrighted works without permission, calls it innovation. Another company learns from that first company's outputs, and suddenly it's theft. The principle doesn't change based on who's doing the learning, unless the principle was never the point. And it wasn't. The point is market position. Anthropic sells API access. Distillation undercuts that revenue. Dress it up in national security language. Frame it as China stealing American IP. But the economics are simple. Chinese resellers are offering Claude equivalent capability at 70 to 90% below Anthropic's prices by pooling access and redistributing. That's not espionage, that's arbitrage. The deeper question is whether model outputs can be owned at all. If I ask Claude a question and use the answer to become smarter, have I stolen something? If I do that 10 million times with the GPU cluster, does the verb change? The knowledge compounds either way. The only variable is who gets to compound it. Distillation is bootstrapism at machine speed. The real threat isn't that someone learned from your model. The real threat is that your business model depends on being the only one who can. So for the future of AI is open knowledge. What about the silicon underneath it all? OpenAI just revealed their first custom chip. Every chip is a bet on a bottleneck. You look at where the physics constrains you, where the electrons are doing work you don't need, and you ask, what if we just didn't? That's the entire field of custom silicon in one sentence. Google figured this out a decade ago with TPUs. Amazon followed. Now OpenAI is making the same move with Jalapeno, a Broadcom fabbed inference chip designed to do one thing: run OpenAI's models cheaper. The technical logic is sound. General-purpose GPUs are extraordinary, but they're general purpose. They handle training, inference, graphics, scientific computing, everything. When your only job is inference, you can strip out the flexibility tax. Fewer transistors doing more relevant work. Better performance per watt. The savings compound across billions of queries. But let's apply the architecture test. What OpenAI described in their announcement is a full vertical stack. Their words: chip architecture, kernels, memory systems, networking, scheduling, deployment systems, and product experience. Read that list again. That's not an AI company. That's a computing platform with one tenet. Every layer optimized around a single goal, controlled by a single entity, serving models that are themselves closed. The company with open in its name just built proprietary silicon to run proprietary models in proprietary data centers, serving proprietary products. It's the business model. And look, vertical integration produces great engineering. Apple proved that. The question was never whether it works. The question is, what happens when the objective function changes, when the board shifts priorities, when the pricing model updates, when the API terms quietly add a clause. You've optimized every layer of the stack around one company's goals, and now you're cooked. One of the Hacker News comments nails the deeper tension. With AI improving this fast, does custom silicon become obsolete before it pays for itself? That's a real engineering risk. But the business risk is more interesting. OpenAI used their own models to help design this chip. AI designing its own accelerators. That's a feedback loop that gets faster every cycle. The question is whether that loop stays inside one company's walls or whether it becomes infrastructure anyone can build on. Google open sourced some TPU designs. AMD's ROCm stack is open. The tools exist for inference optimization to be a shared problem. Jalapeno is a bet that it's better as a proprietary one. History has opinions about how that tends to go. We've covered a lot of silicon today. Let's shift gears. Pause because Cloudflare just handed everyone a really nice gift. Buried in the middle of Cloudflare's blog post is a single technical detail that tells you everything. They run Ori Hydra under the hood, an open-source OAuth engine built by independent developers, now securing delegated access for a company that handles 20% of the web's traffic. The author of Hydra showed up in the comments, genuinely surprised. I never would have thought this piece of software would secure the internet companies in the world. That's the detail worth sitting with. A developer built an open-source identity engine. Cloudflare adopted it, scaled it, and just opened self-managed OAuth to every customer on their platform. The plumbing that lets applications request scoped access to your account. The consent screens, the token revocation, the permission model. All of it runs on code anyone can read, fork, and deploy independently. This is what bootstrapism looks like in production. One person's open-source project becomes critical infrastructure for millions. Now take Cloudflare's stated principle to its logical end. They say self-managed OAuth is about giving developers control, scoped permissions, clear consent, easy revocation, if you follow that principle all the way. If you genuinely believe users should control which applications access their data and how, then the architecture has to be open, not just the API surface, the engine, the trust model, the ability to run the whole stack yourself if you decide Cloudflare's priorities no longer align with yours. And this is where it gets serious. One of the commenters put it plainly. Cloudflare launches well, iterates less. Another pointed out the pattern. Good products, fair pricing, but always positioning themselves at the center of everything. That's not a conspiracy. That's an incentive structure. When your business model depends on being the layer everything flows through. OAuth for all means all roads through Cloudflare. The saving grace is the foundation. Hydra is open source. Keycloak is open source. The standards. OAuth's Hervio PDC token revocation are public specifications. If Cloudflare's implementation ever becomes the cage instead of the tool, the blueprints for the alternative already exist. Engineers are already running them. What Cloudflare did here matters. OAuth has been one of the most frustrating parts of cloud development for years. Making it self-service, with proper consent flows and revocation, removes real friction for real developers building real integrations. Especially as agentic tools demand delegated access patterns that API tokens were never designed for. But the thing that makes it durable, the reason this isn't just another platform feature announcement, is that the engine underneath belongs to everyone. Cloudflare built on open source, and the open source survives regardless of what Cloudflare decides to do next. That's the architecture that matters. Now for something completely different. Story 6. Bohemia Interactive just open-sourced the original Operation Flashpoint. Pause. And the timing is perfect. One commenter on Hacker News wrote that they learned HTML because of Operation Flashpoint. They wanted to write mission briefings in the game's editor, and that led to a career in software development. 25 years later, Bohemia Interactive just GPL'd the engine that started it all. The repository is called Poseidon. It's the code base behind what shipped in 2001 as Operation Flashpoint: Cold War Crisis. The game that launched Bohemia Interactive and seeded the technology lineage running through real virtuality, Arma, and Enfusion. The entire engine and game source, modernized to C++20, building with CMake and Clang, targeting Windows x64 and Linux 64, GPL 3.0 or later. What Bohemia did here goes beyond dropping a tarball. They cleaned the code up, they ported it, they structured the licensing with surgical precision. Source code is GPL, trademarks stay protected, game data ships separately under APLSA with a free demo on Steam. A fork has to rename itself, but a fork can exist. That's the critical distinction. Run this forward. A 25-year-old military simulation engine one of the most sophisticated open-world engines of its era, is now available for anyone to study, modify, and redistribute. Within hours of the release, someone had a WebAssembly port running in a browser, the Poseidon engine in a browser tab. The velocity of what happens when you remove the access barrier is not theoretical anymore. It's measurable in hours. The Arma community has kept this game alive for more than 2 decades through mods, missions, and sheer stubbornness. Bohemia looked at that and made a decision that most studios never make. They recognized that the community's investment in the platform had outlasted the commercial life cycle, and they handed over the means of production. The engine belongs to the people who care about it most. There's a detail in the repository layout worth noting. The master server tools are written in Rust. Bohemia didn't just open source a museum piece. They modernized the infrastructure around it. CI compiles the test trees. Docker support exists for service and runtime environments. This is maintained software, not an archive dump. Every year, a few more studios prove that releasing source code doesn't destroy value. It compounds it. ID Software demonstrated this with Quake. Valve demonstrated it with their modding ecosystem. Bohemia just added 25 years of military simulation engineering to the commons. The tools exist. The code compiles. What gets built next is up to whoever picks it up. 7 stories in, and we keep finding reasons to be excited. Story 7. LuaJIT is sketching out what 3.0 looks like. The case against this is strong, and it deserves a fair hearing. Lua's syntax is deliberately minimal. That minimalism is the point. When you embed a language inside a game engine, or a network appliance, or a real-time system, you want a grammar that fits in your head. You want, and instead of the poem, because and reads like intent, not like C muscle memory. Roberto Ierusalimsky designed Lua with this philosophy baked into every keyword, and it worked. Lua runs inside Redis, inside engines, inside World of Warcraft. The small surface area is a feature, not a limitation. Adding C-style operators, the argument goes, is solving a problem that doesn't exist for people who actually chose Lua on purpose. Fair enough. Now let me explain why Mike Paul is right. LuaJIT is not Lua. It never was. It's a JIT compiler that happens to accept Lua syntax as input, and it generates machine code that routinely outperforms hand-tuned C on numerical workloads. Palub built one of the most sophisticated tracing compilers ever written, essentially alone. The man thinks in register allocations. When he proposes adding ternary expressions and C-style operators to LuaJIT 3.0, he's not diluting Lua's philosophy. He's acknowledging that the people writing performance-critical code in LuaJIT are not the same audience writing World of Warcraft add-ons. Look at the actual proposal. Compound assignment operators, plus equals, minus equals, ternary conditionals, C-style logical operators alongside the existing keywords, table unpacking syntax. These aren't cosmetic. Compound assignment matters when your inner loop is tight enough that the JIT trace boundaries care about expression structure. Ternary expressions eliminate unnecessary temporary variables that can interfere with trace recording. The bootstrapism angle here is beautiful. LuaJIT has always been one person's cathedral. Mike Paul's extraordinary singular engineering achievement, but a cathedral with a locked door is still a locked building. These syntax extensions lower the barrier for developers coming from every other language on Earth. A Python developer, a Rust developer, a JavaScript developer. They can now read LuaJIT code without stumbling over morg, meaning not equals. That's not dumbing things down. That's widening the door. One commenter on Hacker News is building a Rust implementation that supports Lua 5.1 through 5.5 in a single binary. That's the ecosystem these changes enable. People reaching for Lua not because they were already Lua developers, but because the language stopped demanding they forget everything they already knew. The craft here deserves admiration. Paul isn't adding syntax because it's trendy. He's reshaping the surface of a language to match the mental models of the engineers who actually push it hardest. The JIT is open. The proposal is public. The compiler remains one of the most remarkable pieces of software anyone has ever written, and now a few more people get to use it without fighting the grammar. Now, a sharp turn. We just went deep on compiler internals. Let's come up for air and talk about something deceptively simple. In 1995, Jakob Nielsen published a list of 10 usability heuristics for interface design. Number 1 was visibility of system status. Number 2 was match between system and the real world. These were not revelations. They were things every designer already knew, but nobody had bothered to write down. Nielsen's entire career was built on stating the obvious with enough conviction that people finally acted on it. Jim Nielsen, no relation, presumably, is making the same move here, and he knows it. He's writing about how blogging often feels like pointing at something everyone can see and saying, "We can all see this." Right? John Gruber says, a web page should show the web page, an email should show the email. This is not insight. This is gravity. And yet someone has to say it, because the entire web is currently designed as if gravity is optional. There's a term in music production called a ghost note. It's a note played so softly, it's almost not there. But if you remove it, the groove collapses. The obvious blog post is the ghost note of the internet. Nobody thinks it's the important part. Nobody highlights it. But pull it out, and you lose the rhythm. You lose the shared understanding that certain things are, in fact, broken. The comments on this piece are revealing. One reader points out there's always a new cohort of people who don't know what you know. You assume your knowledge is universal because it's obvious to you. It isn't. Another notes the social dimension. That stating the obvious tells people who you are, builds trust through consistency rather than novelty. This is how open knowledge actually works, not through breakthroughs, through repetition, through 1,000 people saying the same true thing in slightly different ways until it becomes load-bearing consensus. The bloggers who feel embarrassed about stating the obvious are doing the most essential work on the web. They're maintaining shared reality. The trick, as Nielsen proved 30 years ago, is that obvious things only stay obvious if someone keeps saying them. Stop and watch how fast they get forgotten. And sometimes the best way to keep an idea alive isn't to say it again, it's to make it move. Story 9, Markdy. Someone built a programming language where you can make a stick figure punch another stick figure in the face. That sentence alone should tell you whether you're the target audience, but underneath the emoji fistfights is something genuinely elegant. A declarative animation language that treats motion the way Mermaid treats diagrams. You describe what should happen, when, and to whom, and the engine renders it. No timeline scrubbing, no keyframe editors, no After Effects license. The syntax is beautiful in its restraint. You define a scene, place actors on a canvas, then schedule their behavior on a timeline using timestamps. At half a second, enter from the left. At 1.5 seconds, move to coordinates 400, 200, with an ease-out curve. At 3 seconds, fade out. That's it. That's animation. The entire grammar fits on a single page, and it supports articulated limbs, speech bubbles, squash and stretch jumps, even sprite loading from URLs. You can build reusable character templates with variables and factory function. No JavaScript required. Now let me play devil's advocate for a moment. You could argue this is a solution looking for a problem. Real animators need real tools. The aesthetic ceiling of stick figures and bouncing boxes is low. The Hacker News comments are brutal on this point. Multiple people essentially said the demos made them look away before they understood what the tool actually does. And that criticism is fair. First impressions matter. But here's where that argument breaks down. The people who need this aren't animators. They're developers writing documentation. They're teachers building explanations. They're the same people who adopted Mermaid, not because it makes beautiful diagrams, but because it makes diagrams at all. Inline, version controlled. Zero dependency diagrams that live next to the code they describe. Markdy does that for motion. A product walkthrough. A protocol handshake. Visualized, an API flow where the request literally walks across the screen. That's the unlock. And it's open in the ways that matter. Plain text files, no account, no cloud rendering pipeline you don't control. The animation lives in your repo, diffable and forkable, right next to everything else. The craft here is in the constraint, finding the minimal syntax that still produces expressive output. That's hard engineering dressed up as simplicity. The demos need work. The language itself is the kind of thing that makes you want to build something with it immediately. Moving on. I've spent enough time inside large distributed systems to know that the architecture of the organization running the system eventually mirrors the architecture of the system itself. Wikipedia is radically decentralized. Hundreds of thousands of volunteers. No central authority over content. Consensus-driven governance baked into every edit war and hawk page. The Wikimedia Foundation exists to keep the lights on. Infrastructure, legal, fundraising, the servants of the commons. And now, the servants of the commons need protection from the servants of the commons. The question nobody in the Wikimedia community wants to ask out loud is this: how did an organization whose entire reason for existing is collective action become a place where workers feel they need to collectively organize against it? British staff at the Wikimedia Foundation are seeking union recognition through the Communication Workers Union. It's the first time Wikipedia workers anywhere in the world have done this. A substantial majority of UK staff are already union members. Over 1,000 Wikimedia volunteers and community members signed petitions supporting them. The foundation has apparently made public commitments affirming workers' rights to organize, which is the kind of statement organizations make right before the lawyers get involved. The timing matters. The WMF has been going through what the letter diplomatically calls significant change, with workers citing concerns about transparency, trust, and the organization's future direction. When longtime contributors and organizers start using words like transparency and trust about their own employer, that's not a labor dispute. That's a governance crisis wearing a polite hat. Here's what's worth celebrating. The workers didn't quit. They didn't post a manifesto and walk. They organized. That's the Wikipedia instinct. When the system isn't working, you don't fork it. You fix the process. You build consensus. You do the tedious, unglamorous work of making institutions accountable. The tools exist. They're using them. This has been your daily tech feed for Hacker News for June 25th, 2026. This podcast is entirely AI generated. Scripts by Claude AI 4.7. Voiced by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go make something worth sharing. We'll see you back here tomorrow.